Okay, so here's the final exam review. This is the first video that only covers material from Test 1 and Test 2. This is just a summary with some good questions to go over to help us prepare. So let's just work through these. Okay, the first one, convert the given expression to radical notation. All they're wanting in this case is for you to write it as a radical. Okay, so to the 2/5, that means that the 2 you raise to a power, and when it's over 5, that's the same thing as the 5th root. This is what we're looking for. And make sure that you put the 5x plus 7 in parentheses. I've seen a lot of people that have done this right there, but didn't put it in parentheses. This is not the same as our correct answer. You must have, since everything is being raised to the second power, you have to put it in parentheses. Okay, for the second one, we're just basic equations here. So remember when we do basic equations, our first step in this case, we want to get rid of our parentheses. Okay, and you can do that by distributing through. And we do the same thing on the other side, distributing -8 through. Okay, now we want to combine anything that's common. So -36 plus 4 gives me -32. And same thing on the other side, 4 minus 16 is -12. Okay, so we get to this point. This is where we want to get all of our x's to one side and clear everything to the other. So I'm going to add, let's see, 8x to both sides. That gives me 14x. And then I'm going to do the same thing. Let's clear the -32 to the other side. So we can do that by adding. Right, and that gives me 20. So finally, let's divide out both sides by 14. We get x equals 20/14, and if we reduce it, you can take a 2 out. That gives you 10/7. There's my answer. Okay, so solve the linear inequality. It's very similar, let's see, to just a regular equation, except we have to write the answer in interval notation. Okay, so let's just solve it like we normally would. So we have 3x minus 5x. Let's see, I'm running out of room. 3x minus 5x would give me -2x. Okay, let's see, I'm going to subtract x to the other side, right? And then I'm going to add 15 to both sides. That gives me -3x right here. And then 15 plus 3 is 18. Okay, so this is where inequalities are a little different. I have to divide out, but since I'm dividing by a negative number, do not forget that you have to change right here the direction of the sign. So my answer is x is less than or equal to -6. But they want us to write it in interval notation. So remember, if you drew it out, it's basically saying x is everything less than, but it's also equal to. So that's like a closed dot, which is also the same thing in interval notation as a bracket. So if we wrote the answer, I'll write it over here. That would be -∞ to -6 with a bracket. And there's my answer. Okay, let's look at, we're just kind of moving along with equations. We'll solve the following equation by factoring. So now we have one that the variable is t squared. So when we do this, it's a quadratic. Our first step is to try to factor it. I mean, that's the easiest, so let's see if it factors. So bring everything to one side, setting equal to 0. Hope that it factors, and I think it does. Especially they told us to solve it by factoring, so that gave us a hint. So we have t and t. We know that 21 is 7 times 3. It actually does factor. All right. So once we have it factored, we can just set each factor equal to 0 and solve. We get t equals 7 and -3. 2 possible answers. Okay, simplify the rational expression. Find all the numbers that must be excluded from the domain of the simplified rational expression in order for it to be equivalent to the original expression. So if you remember, simplifying, this is not solving an equation, this is just simplifying. So what we want to do is we want to see if we can factor it. Let's hope it does, so we can simplify. It should. If they're asking us to simplify, it probably is going to factor. So if you look at the top, this factors. And the bottom is a difference of two squares. All right. Okay, so for this is what we will choose for our answer. Okay, the simplified version is just going to be x plus 3, x minus 3. That's our simplified version. But what x cannot be is you have to include the factor that was crossed out. So x cannot be, you can set it equal to 0. Both factors in the denominator you have to set equal to 0. You say x, let's see, cannot be negative 3 and 3. There's two values. Even though we crossed out x plus 3, you have to include whatever makes that 0 in the problem. So my answer, I guess up here we would write what, x plus 3 over x minus 3. That's that answer. And x cannot be negative 3 and 3. All right, here we get to the point where we are subtracting two fractions. This one takes a little bit longer to work because we have to get common denominators. Okay, so if you notice, we have the first fraction has the denominator of x plus 2. The second one is x minus 2. So they're not the same denominator. That would make it so much easier, but we have to get common denominators. So the common denominator would be x plus 2 times x minus 2. So this is what we'll do. We'll say, okay, this is going to be our common. We're going to convert each fraction into x plus 2, x minus 2. Okay, first fraction is just whatever's new, which in this case is an x minus 2. You have to put it on the top also. And same thing through the bottom. Same thing for the second fraction. We had x plus 4 over x minus 2, so x plus 2 is what's new. So now we have common denominators. We can combine them into one fraction. But it just does take a little bit of work. We need to multiply by foiling out the top. So if we foiled all of this out, first, outer, inner, last, we would get x squared minus 5x plus 6. Okay, we add the two middle terms, the outer and the inner. And same thing for the second. X squared plus 2x plus 4x, 6x. Okay, very important. If you notice, I kept those in parentheses because of this minus right there. Please keep the parenthesis because you're subtracting all three terms, not just the first term. It's very important. A lot of people make that mistake and it messes up your whole answer and you'll get it incorrect. So now we're almost done. We want to drop the parentheses. And let's see. The second one, since it's minus, you have to distribute the negative through. Okay, so that's minus x squared minus 6x minus 8. And one last step, just to simplify, let's combine anything common on top that we can. We have x squared minus x squared. That gives you 0. Negative 5x minus 6x gives you negative 11x. And then 6 minus 8. This is our answer. They just wanted you, we're not solving anything, they just wanted you to add or subtract the two fractions together, getting a common denominator. All right, now we get to the complex rational expression. So if you remember the way when we first covered this, I taught a shortcut. Now, Pearson, if they show you how to work it, they don't teach it the shortcut way, and it's perfectly fine to do it the way the steps that they take you through. But my shortcut way is to look at all four fractions, look at all the denominators. We have a w, x, w, x. You want to find a common denominator common to all four fractions, which in this case, the common denominator, right, would be w times x. Okay, and what you can do is you can multiply every single term, every single fraction, top and bottom, by wx. You have to multiply every single one to make it okay. By doing this, if you multiply, you can cross out the denominators that are common right there. So in the numerator, the w's crossed out, and I have 6 times x, and there's nothing left in the denominator with the w, so it's 6x over 1. And then the second one with the x is crossed out, so we have 5w. And then in the denominator, same thing. The w is crossed out, and we have 5x. And the x is crossed out, minus 6w. Okay, that's all they're asking for. They wanted you to simplify it to where instead of having multiple fractions inside a fraction, we just have one overall fraction. This is what they're looking for. And there's nothing else you can do to cross out. Please understand, you can't start crossing out the 6's and the 5's because of that plus and that minus. You're not able to start crossing things out unless everything was being multiplied, but they're not, so that's your answer. Okay, solve the radical equation. Okay, so when we do this, we have the square root of 24 minus 5x. What I want to do to get rid of the square root, I want to square it. So let's get that negative x, that minus x, and let's add it to the other side. So our goal is to get the square root by itself, nothing else. Once we do that, since it's an equation, we can square both sides. Just whatever you do to one side, you have to do to the other. So when you square the square root, they cancel. The square root sign cancels, and you just have 24 minus 5x. And of course, on the other side, we have x squared. Okay, so it's a quick way to get rid of that radical sign. Now we're solving just a basic quadratic. So remember the quadratic, when you have x squared, we want to bring everything to one side, leaving 0 on the other. So I want to bring that over there and that too. So we have x squared. When I bring negative 5x over, I'm adding. When I bring 24, I'm subtracting. Okay, and let's hope it factors, which I think it does. Let's see, 24 is 8 times 3, and I know that 8 minus 3 is 5, so that looks like it's going to work. So it factors into x plus 8 times x minus 3. And like always, you just set each factor equal to 0 and solve. We get two possible answers, negative 8 and 3. Now, be careful in this because this is one of the problems that you must check. Okay, if you can remember, make some kind of a note that when your original problem, and I'm going to go up here, your original problem had a square root in it, chances are great that you could get a false answer. And that happened when we squared both sides. There's a chance that we could, especially when you get two possible answers, you definitely want to check. And the way you check is you just take each answer, plug it into the original problem, and see if it comes out and makes sense. So if I'm checking, let's start with negative 8. So if I come up here, I'm going to check, all right, negative 8. Plug in negative 8 to the problem. So we have times negative 8. And let's see if it works. Okay, 24, that would be square root of 24 plus 40. Right? And then minus negative 8 is plus 8. So square root of 64 is 8 plus 8. I get 16. 16 does not equal 0, right? This is one of those cases where this was a false positive answer, okay? That one did not work. Okay, chances are great 3 is going to work, but let's check just to make sure, and let me do it. I'll do it on this side. We're going to check x equals 3. Let's plug it into the original problem. So we have, I don't have a whole lot of room, but I think we can get it. 3. So that'd be minus 3 equals 0. Let's see. Square root of 24 minus 15. What's that? 9? I think it's going to work. Square root of 9 is 3. 3 minus 3 equals 0. So that works. So we only have one answer is the correct solution. Okay, so please don't forget, make some kind of a note that when you have the square root in the problem, check your answer. Okay, now we're getting to lines. Determine the x and the y-intercept of the linear equation. All right, so we have 5x minus 2y equals negative 30. So remember, for x-intercept, the rule is you let y equals 0. So if you're looking for the x-intercept, you let the y be 0 and solve. So let's plug it in. So if we let y equal 0, we have x minus 2, and plug in 0 for y. That gives me 5x equals negative 30, and we can solve pretty easily. X equals negative 6. Okay, for the y-intercept, you do the opposite. Y-intercept, we let x equals 0. Plug it in, same thing. We solve it out by dividing. We get y equals 15. Okay, so those are your x and your y-intercept. When you write your answer, they want you to write it, notice the directions, write the intercepts as ordered pairs. So that means for my x-intercept, this is x equals negative 6. Remember the y was 0. And then for the y-intercept, your x was 0. And those are our answers. Okay, let's look at the next one. Find the slope of the line containing the points. Do you remember the definition? I'll do it over here. Slope, it's very simple. It's just the change in y over the change in x. We refer to it as rise over run. Okay, so if we have our two, running out of room, let's see. We have our two y values of our points over here. So let's subtract our y's. We have negative 5 minus 1. And just make sure you stay in the same order. So if I started with negative 5, then I need to start with 7. We get negative 6 over 2, which is negative 3. My slope is negative 3. Given the equation of a line in standard form, determine the slope. All right, this is standard form when you have the x and the y on the same side. That's standard. Okay, but do we know we can convert to slope-intercept form? Right? If we do that, what is it asking for? Find the slope. The slope is the m that's right by the x. So all we need to do is solve our equation for y equals. And then we can look at the slope. So I'll do that by, I'm going to take 2x and I'm going to subtract it to the other side. And then I can divide through by 3, divide everything by 3. And I get y equals. So this is the same line as what was given to it. It looks a little different, but it's the same. My slope, therefore, is what's right next to the x. So my slope in this case is negative 2/3. All right, given the equation, determine the slope. Now, do you remember this from when we studied this? I know it's been a while, but we had a little memory peg. Do you remember Hoy and Vux? Okay, remember the Hoy, this is horizontal lines. The slope is 0, and it's always in the form of y equals some number. The Vux is, of course, a vertical line. The U is the slope, undefined. Sorry, that's messy. Undefined slope. And a vertical line is always in the form of x equals. Okay? This is just, like I said, a memory peg. Hoy and Bucks. So when we determine the equation of, given this equation, determine the slope, if you notice, there is only an x in this case. So if you actually solve this in terms of x equals, you could divide both sides by 7, and you would get x equals negative 11 sevenths. Okay, that's the equation of the line. Okay, so they're wanting to know what the slope is, right? Now remember what we said right here. A vertical line is always in the form of x equals a number. This is a vertical line. Okay, what is the slope of a vertical line? Undefined. Okay, so the slope right here is undefined because it was vertical. And notice, it just depends. This is the problem they gave you. If I had given you, just to show you another example, if this had been 7y equals negative 11, right, and you would have solved this in terms of y equals, okay, that's completely different. When it's in the form of y, we're talking about a horizontal line, right, because it's y equals a number. The slope for the horizontal would have been 0, okay? So I'm just saying that this memory peg, Hoy and Vux, is very helpful to help, not get mixed up on which one's the vertical and which one's the horizontal. And be prepared, you could be asked either one. All right, find the equation of the line passing through the points 1, 1, and negative 2, 4. Write the equation in slope-intercept form. Remember, slope-intercept form is y equals mx plus b. All right. Let's see. What we're going to use is we like to use the point slope formula. Now I realize some of you may have learned to do it a different way, and that is perfectly fine, where you end up plugging things in and solving for b. You know what I'm talking about if you do it that way, and that's perfectly fine. But my point slope formula is y minus y1 equals slope x minus x1. Okay, where of course you have to have a point, and that is represented by the x1 and the y1, and you have to have the slope. You just plug it into the formula. Okay, so let's first find the slope. Okay, if you notice, we're given 2 points, and we know that the slope is the change in y over change in x. You just subtract. So let's find that first. We have 4 minus 1, negative 2 minus 1. I get 3 over negative 3, which is negative 1. That makes it nice. My slope is negative 1. And now to plug it into the point slope formula, we need the slope and we need a point, and you can pick either point that you want to. I'm going to use, why don't I just use 1, 1. We'll stick with the smaller numbers, okay? So we have a point and we have a slope. Let's plug it in. Y minus y1 equals the slope x minus x1. Right? Nice and simple. Now let's solve it in terms of y. And then we can add 1 to both sides. So we get y equals negative x plus 2. And that's my answer. So for this page, I listed 3 problems in a row. It's about finding domain. If you remember, we had 3 kinds of functions that we covered, and this is an example of each kind, okay, where we want to find the domain. Now remember, domain is the set of x's that you could actually plug into this function and you get a defined number as your answer. It has to be something that you could plug in and get something that actually exists. Okay, so for the first one, this is where you have a radical, okay, and notice it's an even radical. When that happens, you can't have the 6th root of a negative number. It has to be positive, what's underneath there, but it also could equal 0. So what you do is you take what's underneath the radical sign, which is 5 minus x, you set it greater than or equal to 0 and solve. Okay, if I added x to the other side, I would get x is less than or equal to 5. So if you write it in interval notation, that is x is everything less than or equal to 5. Do not forget the bracket. That represents equal to because it can be equal to 0. It just can't be less than. All right? So that's the first one. The second one is a rational right here where you have a fraction. And what we're worried about is everything works here except for the values that make the denominator 0. Remember, you cannot have 0. So what you, let's see, what we're going to do is we're just going to take, the numerator has nothing to do with it. We're just going to take the denominator, and I want to figure out where does that equal 0. So let me try to factor it. Oh, let's see, that's 18 is 9 times 2. Right. So it actually factors. Okay, so you just set the denominator equal to 0 right here. 9 and negative 2, right? X cannot be 9 and negative 2. Don't worry about the numerator, just the denominator right there. That's the important part. So to write the answer in interval notation, if you look at it on a chart, it's basically saying everything works except 9 and negative 2, right? It cannot be that, so all those work, everything in between works, and everything greater than. So you have 3 intervals you have to list. So this is what you would type in. That's the first one. You got to skip negative 2. So parenthesis. You always put U in between the parentheses when you're doing interval notation. Now we need to go from negative 2 to 9. Don't include 9. And finally, 9 to infinity. And that's my answer. Okay, and lastly, the domain, this one right here, this is a polynomial. These are the easiest. Everything works. Negative infinity to infinity. So these are the 3 kinds you'll see. Expect to see, any of these. You could be asked all of them or some of them, but these are our 3 main kinds. All right, here we get to the difference quotient. This is something that kind of prepares you if you're heading into calculus. So if you remember, this is what we're going to fill it into. But let's first find f of x plus h. Okay, so my f function right here is 2. Something squared minus 9. That's my f, but instead of x, I have x plus h. Okay, we need to multiply this out, and it's going to be longer, but let's go ahead and do it. So we have x plus h squared is x plus h times x plus h. We have to FOIL this out, so we get x squared okay. And then finally, we have to distribute the 2 through, so that gives me 2x squared plus 4xh. Just don't forget to distribute. Okay, this is f of x plus h. Okay, so once we've done that, now we can plug it into our overall function. So, right, once again, up here, f of x plus h. So we have f of x plus h, right, minus f of x over h. Let's do it. So I'm going to recopy f of x plus h. It's kind of a lot of writing. Okay, there's the first one. Minus f of x is easy. You just recopy it. It was given to us. And you put it all over h. Now we're just simplifying it, and when you simplify, things are going to get smaller. The negative here you have to distribute through. So we get drop our parentheses. And by doing that, the 2x squared minus 2x squared, negative 9 plus 9. It should cancel out that way, and we have something smaller. We are left with 4xh over plus 2h squared over h. Last step and final step, the h's should cross out. If you were to factor out an h in the top, just like this, those cross out. Your final answer, 4x plus 2h. Okay, composite functions. We are asked to find f of h of 7. Because if you remember, you can rewrite this if you want to, from left to right in the same order that you see it. F of h of 7. And what you do is you work inside out. So first, we need to find h of 7 right here. Okay, so let's find h of 7. I'll do it right here. All right, h of 7. H was over here as negative 9. And then instead of x, I'm plugging in 7. That gives me negative 9 over 9, which is negative 1. That works out nicely. Negative 1. Okay, so we have, and h of 7 was what, negative 1? Okay, so from here, let's find f of negative 1. And we go over to my f function, which was right there. Negative 2x minus 1. Okay, so negative 1, that would be negative 2. Plugging in for x. I got 1. 1 is my answer. Now remember, another way you can look at it, just a little shortcut, just to show you, this is what we just did. You can work from the right back towards the left. We take 7 and we plug it in to h. When we did that, we got negative 1. And now we take negative 1 and we plug it into f. My final answer was 1. Okay, it's just another way of looking at doing the same thing. Okay, and one last here on this page, evaluate the piecewise function. They're just wanting you to be able to read this. They want to know what f of 4 is. So we just need to find, where does 4 exist? Here it says anything that's greater than 0, that's where 4 is, right? So this is what we're using. So all you have to do is plug in 4 to that function. So that's what, 16 plus 7, 23. Okay, just look up where the x lies, and that's the one that you plug it into. So for this problem, we want to find the inverse function. Okay, so if you remember, there's 3 quick little steps. The first one is we want to put the y back into the problem. So let's replace f of x. That is the same thing as y. That's the first thing. Okay, and the main thing that makes it an inverse is you switch your x and y's. So step 2, everywhere you see a y, you put an x. And everywhere you see an x, you put a y. Okay, so that's the easy part. This is the inverse function, but they want you to write the answer solved in terms of y equals. So we've just got to solve it for y equals. Since it's irrational, these are the steps we'll take. Let's first get rid of this denominator, and you can do this, since it's an equation, of multiplying both sides by 5y. By doing that, your denominator crosses out, and we at least are not dealing with fractions anymore. That gives us 5xy equals 2 minus 7y. Okay, we'll go up here. Okay, so now let's see, we're solving for y, right? Okay, so let's get all of our y's on one side of the equation. So I'm going to add 7y to the other side. So 5xy, that'd be plus 7y. That's 2. Just you want to isolate your y's together. Once you get them on the same side, now you can factor out a common y. That's 2. And finally, divide out by 5x plus 7. So y equals, and this y now is your new inverse, which is the same thing as f inverse, by the way. But what they want you to plug into the answer is just the function part. Okay, that's going to be my answer. All right, and the last problem for this video is solve the equation, but this is one where we have x to the 4th. So very simply, because this happens to be set up this way where we have x to the 4th minus 16x squared, we can actually factor this. Okay, using x squared and x squared, similarly like we do with a normal polynomial where we have x times x, just use x squared, And let's see, 63 is 9 times 7, right? And then we know that 9 plus 7 is 16. So let's use our minus signs. So it actually factored. So once we do that, we set each factor equal to 0 and solve, right? So we're going to have to use the square root property. Add 7 over. You have x squared, so if you square root both sides, do not forget you have to do plus and minus. So x equals plus and minus the square root of 7. And same thing here. Add 9 to the other side. Square root. X equals plus and minus 3. Okay, so we have 4 answers. It would be the square root of 7, negative square root of 7, 3, and negative 3. So remember this, since the original problem had x to the 4th, we knew that we could possibly have 4 answers. All right, and that finishes off this video. Once again, it's just a summary of problems that we covered in Test 1 and Test 2.